Dear students, good morning, good afternoon, and good evening. Based on the time zone at presently you are staying. First of all, I welcome all of you for our YouTube channel. You know very well, I am Selva Mani Krishnamurthy sitting in front of you. This is Machine Learning video lesson number 15. So far, we studied supervised learning, regression, classifications, we studied. From this lesson onwards, let us start unsupervised learning. Very beginning, we studied machine learning class into two categories. One is supervised learning, another one is unsupervised learning. So let us, from this lesson onwards, let us start unsupervised learning. I hope it is clear. So as usual, I like to share my screen. I hope my screen is visible to all. Good. So machine learning for beginners, lesson number 15, topic is unsupervised learning. K means clustering using Excel. That is what we are going to study. First, let us study classifications of machine learning. Machine learning broadly classified into supervised learning and unsupervised learning. Again, supervised learning is classified into classification regression. This is what we studied so far. Unsupervised learning again classified into two categories: clustering, principal component analysis. First, let us study what do you mean by supervised learning. Then we can go for what do you mean by clustering. Then we can go for K means clustering algorithm. Unsupervised learning. In supervised learning, we are giving trained data, that is input with the label. Trained data, trained input with label we are giving. Whereas in unsupervised learning, we are giving only inputs, no label, without label. That means unlabeled training data we are giving to system. See, in this case, we are giving different photos of many fruits. There is no output, there is no label, which is apple, which is mango, which is avocado, we didn't give. But system accept all photos of fruits. It recognizes based on the color, based on the size. So it kept all red color fruits separately, all yellow color fruits separately, all triangular shaped fruits separately. This is called as unsupervised learning. In supervised learning, we are training the system with the input and the label. Whereas in unsupervised learning, we train the system without label. That you need to understand. See it here, in unsupervised learning, we don't need to supply labeled data. Here, label means output. System itself assembles or groups unsorted information based on the resemblance of patterns, variants without any training of data. Example, here we provide unlabeled data, that is photos of different kinds of fruit to the system. The system look for the pattern. It may be a shape, it may be a color, it may be a size in the data. Then it group the fruits based on those patterns. Color-wise, all red color fruits kept separately, all orange color fruit kept separately. Shape-wise, all rectangular color avocado kept in separately. This is what unsupervised learning. Under unsupervised learning, we have two classifications. One is clustering, another one is principal component analysis. Now, let us go for clustering algorithm. Clustering means nothing but group. Clustering algorithm is used to group similar data points together based on the features. It is suitable for discovering hidden patterns and structure within unlabeled data. So clustering means grouping of data or grouping of data set or grouping of input data. There are two types of clustering. Many types of clustering are there, but these two only we are going to study. One is key means clustering. Second one is hierarchical clustering. In this lesson, let us study key means clustering. See, key means clustering means what? we have certain set of data point. We need to group. We need to group based on the distance between the nearest data point. The concept is said to be K-means clustering algorithm. The steps involved in K-means clustering algorithm. Number one, select randomly K, that is number of the clusters. K may be any number. For example, we are having 8 data points. Okay, so let us select 3 number of cluster. That means all of the 8 data points should be assigned to any one of these 3 clusters based on the closest distance, the lowest distance, nearest data point can be grouped. All nearest data points can be grouped as 3 clusters if randomly K selected. Then first step is we need to randomly select value for K, that is how many clusters we want to create or we need. Second point, randomly select centroid point for each cluster. For K cluster, we need K centroid point. In this case, if you select the value of K is 3, we want to create 3 groups. So 3 centroid point we needed. Randomly, we can select any 3 data point as 3 centroid point. Step number 3, assign each data point to nearest centroid point. Already we have 8 data point. Out of this 8 data point, we assign 3 as a centroid point. Then all 8 data points should be assigned to any one of these 3 centroid points based on the distance between data point to centroid point. That means what? We need to find out the distance between data point to all centroid point. Which distance is very much low, the data point should be assigned to that particular centroid point. First step. Step number 4, find new centroid point. First time we randomly select centroid point. Now find new centroid point by finding average of the data points already assigned to old centroid point in step 3. Already all 8 of data points are assigned to any one of these 3 centroid points. Whatever data point assigned to one centroid point, we need to find out average of the data point assigned to centroid point 1. Okay, that average should be considered as new centroid point 1. In same way, new centroid point 2 we need to find out, new centroid point 3 we need to find out. Repeat step number 3. Once you find new centroid point, once again, all 8 data points should be assigned to new centroid point based on the lowest distance. Repeat step number 3 and 4 until there is no change in old centroid point and new centroid point. Okay, so the same procedure, step 3 and step 4 should be repeated until we get there is no change in old centroid point and new centroid point. That means now all data points are assigned to any one of K clusters with the K centroid point. We can conclude. These are the steps involved in K-means algorithm. Nothing to worry, I will explain each and every things by having a small example. See, consider the following data set with 8 data points. We are having 8 data points, P1, P2, so on to P8. This is X, Y. That means P1 means 2, 10. P2 means 2, 5. Our aim is these 2 8 points should be grouped into different clusters based on the distance. The nearest data point should be clubbed together. That is what our aim. Step 1, already what we said, randomly we need to select number of the cluster. Assume here I select K equal to 3. That means all data points should be assigned to any one of these 3 clusters because K value is 3. All these data points should be assigned to any one of these clusters. Step number 2, data points P1, P4 and P7 are randomly selected as centroid point for cluster 1, cluster 2, cluster 3. See, C1 stands for centroid point, C2, C3. 2, 10 is P1. 5, 8 is P4. 1, 2 is P7. I randomly selected number of the cluster. I randomly selected 3 centroid points. I hope it is clear. Now, assign each data point to nearest centroid point by finding Euclidean distance. I need to find out the distance between individual data point to each and every cluster centroid point. This is P1, 2, 10. This is centroid point 1, 2, 10. This is the distance between data point 1 to centroid point 1. Same way, this is the distance between data point P1 to centroid point 2. This is the distance between data point 1 to centroid point 3. Am I right? After finding, we need to find out of 3 distance, which is very much lowest, 0 is very much lowest. That means data point 1 can be assigned to cluster 1. See it here, cluster 1. In same way, this is the distance between data point B2 to cluster centroid point 1. This is the distance between data point 2 to centroid point 2. This is the distance between data point P2 to centroid point 3. Out of these 3, which is lowest 3, then we can conclude this P1 is very much closer to centroid point 3. So I assign P2 into cluster 3. In same way, I finish the table. I hope it is clear to all. Now, what is the distance between, what is the formula to find distance between 2 points? See it here, square root of x2 minus x1 whole square plus y2 minus y1 whole square. Here, for cluster 1, P1, C1 is, that is centroid point 1 is x2, y2. So x2, y2 is for C1 is what? 2, 10. Am I right? X1 and y1 normal data point 2, 10. That means x2 is 2, y2 is 10. X1 is 2, y2 is 2. For centroid point 2, x2 is 5, x1 is 2. Y2 is 8, y2 is 8, y1 is 10. By applying this formula, I finish the tabular column. Fine. After that, this is the cluster, I found it. I need to find out new centroid point by finding average of the data point which is already assigned. For example, new centroid point C1 is there. Cluster 1, here are only 1 is there. So no need to worry about average. 2, 10 will be assigned as a new centroid point. Am I right? For 2, here 3 clusters are there. 1, 2, 3, 4, 5. All the 5x needs to be added and average that should be found. That is 6. For cluster 2, all 5y should be added, find y. Average of all x belongs to cluster 2 need to be found. The average of all y's of cluster 2 need to find. Then the average x and the average y should be assigned as new centroid point. Same logic applied to C also. I hope it is clear. Once we find new centroid point, this becomes an already existing cluster point becomes old cluster point. See it here, old cluster. Okay, this new centroid point, this is 2, 10, 6, 6, 1.5, 3.5 should be assigned as cluster 1, cluster 2, cluster 3. This is old cluster. Again, we need to find out new cluster. How same process we have to repeat. Same process we need to repeat. The distance between P1 and C1 need to find out. The distance between P1 and C2, the distance between P1 and C3 need to find out. Similarly, this table should be completed. After that, we need to find new cluster. Out of these 3, which is very much lowest, 1 is 0 is very much lowest. 0 is available in cluster 1. Out of these 5, 4, 2, this is very much lowest. That means P2 is assigned to cluster 3. I finished. Okay. Now new cluster I found. There is difference in old cluster and new cluster. C3, 3, here 2, 1. Again, what do we have to? We have to find another new centroid point by finding average of x of and x and y of all cluster point or data point assigned to each and every new cluster we need to center. Again, we need to proceed. Okay, same process repeated. Okay, here I am checking. Old cluster 1, 1, 3, 3, 2, 2, 2, 1. Here also difference is there. Again, continue. In this stage, old cluster, new cluster, there is no change. Then what we can conclude? Since there is no change in old clusters and the new cluster, there will not be any change in old centroid point and new center, because whatever centroid point we found with the help of this cluster, old cluster, is equivalent to new cluster, because there is no change in old cluster and new cluster. Then we can conclude that all data points are properly assigned to three different clusters. Now let us consider this new cluster is a final clusters. That means what? Now all data points are assigned to any one clusters with k centroid point. That means P1, P4, P8 are assigned to cluster 1. See it here. P1 cluster 1, P4 cluster 1, P8 cluster 1. Same way, P3, P5, P6, P3, P5, P6. All these three data points are assigned to cluster number 2. P2 and P7, P2 and P7, both are assigned to cluster number 3. At last, we create one scatter plot based on X and Y. We got this one. See, these 3 points are assigned to cluster 1. These 3 points are assigned to cluster 2. These 2 points are assigned to cluster 3. Let us check cluster 3. Cluster 3, 2, 5. See here, 2, 5. Again, one more point. Cluster 3, 1, 2 is there. 1, 2. I hope it is clear. Any doubt? Good. Let me demonstrate the same thing in front of you so that you can easily understand. See, already I created an Excel file. Already I typed 3, 8 data point I created. Randomly, I selected K as a 3. That means 3 clusters I needed. I selected already randomly 3 central point P1, P4, P7. P1 is 2, 10. P4 is 5, 8. P7 is 1, 2. I created. Now, what is my aim? I need to find out distance between. I need to find out the distance between P1 and C1. The distance I want to note it down. After that, what I need to find out? I need to find out the distance between P1 and C2. P1 and C3. That I need to find out. Let me check. We know the formula. SQRT of the same formula what I apply. So here 2 is there. 2 is X2 is F3. $F$3. $F$3 minus X1 is this one. D4 whole to the power of 2 plus again dollar. Now G2 is our Y2. Not G2, G3 minus. Okay, now E4 whole to the power of 2. Let me check. I got 0. Is it correct? 0. Fine. Let me drag the same formula here. 0, 5, 8, 7, 7, 8 to so far, no problem. Okay. So this is the distance between P1 and C1. This is the distance between P2 and C1, like this. This is the distance between P8 and C1. In same way, I need to find out the distance between P1 and C2. What I can do? Now, X2 is H5, sorry, H3. H3. X1 is D4. Y2 is I3. I3. Y1 is E4. I hope it is clear. See it here. Let me drag. So 44504471. In same way, we can proceed for cluster 3 also. Now H2 is J3. 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 X1 is D4. Here Y2 is K3. Y1 is E4. E8. Okay, let it drag. So far, no problem. 837775008. So no problem. Now we found the distance between data point and the centroid point. Okay, now we need to find the cluster. Out of this P1 is 2, 10. This 2, 10 is very much closer to 2, 10, C1. So I put C1 here. Out of these three, which is lowest? 3 is lowest. That means P2 is very much close to centroid point 3. So it is assigned for cluster 3. Similarly, 8, 5, 7. 5 is. That means lowest distance is 5. P3 is very much closer to centroid point 2. So we can assign 2. Similarly, we can proceed 0, here 4, again 2, here 2, here 0 is there. So cluster number 3. Here 1 is there, cluster number 2. Let me check. 1, 3, 2, 2, 2, 2, 3, 2. No problem. Okay, these are the clusters. Now what we are to do? We need to find new centroid point. First row is over. We need to find new centroid point. That means the data average of data point assigned to the cluster 1, we need to find out. For cluster 1, only 1 point is there. So 2, 10. No need to find out average. That we can put it. For cluster 2, 1, 2, 3, 4, 5 points are there. We need to find out average of these 3 5 points. That means equal to average of. So cluster 2 x is 8, 5, 7, 6, 4. X is the same way equal to average of y. 4, 8, 5, 4, 9. Okay. Now, same way equal to average of cluster number 3, x is 2, 1. Here equal to average of y. 5, 2. Let me check. C 2, 10, mu C point, centroid point 1. 6, 6, 1.5, 3.5. So far, no problem. Okay. Now, what we are to do? We need to make this centroid point as a new centroid point. Okay. Now, let me check. These 2 points, we can make it as a new centroid point. Then, these 2 points as a new centroid point, C2. Fine. Similarly, these points should be considered as centroid point 3. So far, no problem. Already we have cluster. This cluster should be considered as old cluster. So far, no problem. Now we need to find out the same process, distance between P1 and C1, P1 and C2 like this. We need to fit the column. After that, we need to find out new clusters. Same formula, we can proceed. Let me check. So I think everything fine. F3, okay, no problem. Let me drag it here. 0, 5, 8, 1. Next one, next sheet. Let me confirm 05847 Okay. If any changes, we can change. Same way, we need to find out the distance between all data points and the cluster 2. Let me check. I think everything fine. I got number 6. Let me drag everything. 6, 4, 3, 2, 1, 2, 6, 4. That also fine. Same way, I can find. I need to find the distance between P1 and the C1. Let me drag. Let me check the values. 7, 2, 7, 6, 6, 5 to 6. Any problem? Now I found the distance between all data points P1 to P8 to cluster 1, cluster 2, cluster 3. Now I need to find out new cluster. How we can find out of the three distance, which is the lowest, 0 is the lowest. So 0 is related to cluster 1. So new cluster should be 1. In same way I can proceed. Here 2 is there, I can go for 2. Here cluster 2. Proceed with cluster 2. Here also 2. Here also 2. One is small distance. Here also 2. Here 8, 6, 2. Cluster number 3. Here cluster number 1. Let me check new cluster. What I found is 1, 2, 2, 2, 2, 2, 3, 1. Now let us compare old cluster and new cluster. 1, 1, 3. So difference is there. Again, we need to proceed. What we need to proceed? We need to find out new centroid point by finding average of all the data points already we assigned it to cluster. For cluster 1, 1, 2 data points are there. We need to find out average. Average x of point assigned to cluster 1. 2, comma, another one is 4. Mistakes. Spelling mistake is there. Okay. Here, average x of average y of data point assigned to C1. 10, comma, 9. Good. Now, average x of data point assigned to cluster 2. Average 2 means here 2 is there. Another one is 8 is there. Third one is 5 is there. Next one is 7 is there. Next one is 6 is there. I think 5 data point. 1, 2, 3, 4, 5 data point. Okay. Now, average y of data points assigned to cluster 2. 5, comma, 4, comma, 8, comma, 5, comma, 4. 5, comma, 4, comma, 8, comma, 5, comma, 4. Here, what happened? Average. In same way, I need to find average x of data point assigned to center point C3 equal to average of C3 only 1. That is 1, comma 2. Directly we can put 1, comma 2. 1, comma 2. I think I made a mistake somewhere. This here 1, okay. Here it should be 3. Here should be 3. Okay, fine. Here should be 2. Here should be 2. Here should be 2. Here should be again 2. Here should be 3. Here should be 1. That means 1, 3, 2, 2, 2, 2, 3, 1. Okay. Here first data point is 1, 1. 3, comma 9.5. That is fine. Second onwards, I made mistakes. We need to find out. Equal to average of 2. Second data point is 8, comma 5, comma 7, comma 6. Now, average of y of data point assigned to central point 2. 4, comma 8, comma 5, comma 4. I go correct. Now, average of 1 equal to average of 5, comma 2. Now, let me check. 3, comma 9.5 C1, C2 is 6.5, 5.25, C3 is 1.5 and 3.5. So far, no problem. Fine. Still, there is a difference between old cluster and the new cluster. C11332222222233 is there. Okay, then we need to proceed. Next. That means what? This new centroid point should be assigned here. This is centroid point 2. This is centroid point 3. Okay. The new cluster should be considered as a old cluster. Now, same process we need to repeat. We need to find out the distance between each and every data point to cluster 1, cluster 2, cluster 3. Simply, we'll try to copy because already we created formula. Let me check the difference. Yeah. 177, 552, 727, 336, 616, again 615, 862, 156. So no need to worry, everything fine. If you want, you can check the formula, same formula. It's working fine. Panel we can check. Okay, fine. Now we need to find the new cluster. For P1, 1 is the new cluster 1, which is a lowest distance, C2, sorry, C3. Here, 2, 3s are there. First preference we can go for first point. Since here also 3, here also 3, this 3 is the lowest point. Since cluster 1, we can give first preference. Here, cluster 2. Here also cluster 2. Here, cluster 3. Here, cluster 1. Let me check once again. 1, 3, 2, 1, 2, 2, 3, 1. Okay, no problem. Still, there is a difference between old cluster and new cluster. 1, 3, 2, 3, 2, 1. What I will do? We need to find out again new centroid point. Same way we can follow average of 2, comma, another one is 5, 5, comma, another one is 4. Equal to average of y, 10, comma, another one is 8, comma, 9. We can go for C2. Average of 2 means 8, comma, 7, comma, 6. Average of 4, 5, 4. 4, 5, 4. Now again average of 3. 2, 1. Equal to average of 5, 2. We compare 3.66, 9, 7, 4.33, 1.53. Okay, no problem. So now this is the new centroid point. For next iteration, this should be considered as new centroid point. 1. Centroid point 2. Centroid point 3. Now new cluster of previous iteration should be considered as old cluster. Now we need to find out distance between each data point P1 to P8 to C1, C2, C3. Already we provided the formula, we did it. Same thing, we can copy paste. Okay, so far no problem. Better we can go for only 2 decimal places. Good. It's fine. Randomly we can check. Okay, fine. Check the values. That means 247256780 8514116672766 no problem. Now we need to find out new cluster. That means out of these 3, 2 is lowest distance. P1 can be assigned to cluster 1. Here 2 is very small, then we can go for cluster 3. Here cluster 2. Here cluster 1. Here cluster 2. Here also cluster 2. Here cluster 3. Here cluster 1. Now let me check old cluster, new cluster 1 1 3 3 2 2 1 1 2 2 2 2 3. So now we got old cluster and the new cluster same. There is no change between old cluster and the new cluster. Okay, now let us stop it here. I hope it is clear. So this new cluster, since there is no change in between old cluster and the new cluster, this new cluster can be considered as final cluster. Okay, check it here. Final cluster 1 3 2 1 2 2 3 1. Okay. So now let me create one small scatter chart. Then we can compare. Insert here this scatter chart. This is the scatter chart. That means what? These 3 data points, X and Y is there. These 3 data points are considered as cluster 1. These 3 data points are considered as cluster 2. These 2 data points are considered as cluster 3. For example, let me check cluster 1. Cluster 1, 2, 10 is there. Here 2, this point belongs to cluster 1. Second point is 5, 8. See here 5, 8. Third point is 4, 9. 4, 9. That means these 3 points are grouped as cluster 1. Same way, these 3 points are grouped as cluster number 2. These 2 points, that is 1, 2, 2, 5. 1, 2, 1, 2. Then another one is 2, 5. 2, 5 are grouped as cluster number 3. Now I hope all of you know very well how we grouped the data point based on key means algorithm. Key means algorithm. That means P1, P4, P8 are assigned to cluster 1. P3, P5, P6 are assigned to cluster number 2. P2 and 7. P2 and P7 are assigned for cluster number 3. I hope is it clear to all. Let me stop here itself. I hope all of you enjoy the lesson nicely. Next lesson, let us study something extra. Until then, have a nice good one. Bye bye. See you.